The next page in your Carnegie book looks like this. It's activity 1.2, and we are not going to do this activity. We get to skip it today. So let's move on forward. So welcome to the second part of this lesson. We are going to do another warm-up problem at this point. And the problems we want to look at are number 3 and number 4, the ones we did not do before. So pause the video and take a look at those warm-up questions, warm-up number 3 and 4. Hit play when you're ready to discuss the answers to today's warm-up. All right, if you've hit play, that means you're ready to discuss the warm-ups. For warm-up number 3, there are 60 inches in 5 feet. 60 is our answer to that proportion. And for number 4, there are 16 ounces in a pound. Go ahead and pause right now, and I want you to share different strategies with the class about how you solved these proportions. There's more than one way to solve each of these proportions. You could scale up, you could scale down, you could use cross products. Let's talk about some different strategies and hear how you did it. Very good. Since you've hit play again, that means you're ready to go on. Let's just review our learning goals. We're identifying pi as the ratio of circumference to diameter. We're drawing and labeling some circles, and we really today are going to focus on understanding the formula for circumference and using it to solve problems. And we went over these key terms yesterday. Yesterday, you used a piece of string to measure the distance around the outside of a circle. And we talked about how the distance around the outside of a circle is called its circumference. Today, we're going to add a new vocabulary word, and that word is pi. Pi actually represents a number. So the number pi is the ratio of the circumference of a circle to its diameter. And it turns out that number is the same for every single circle. Here's how you could represent pi using an equation. It's the circumference over the diameter. You could also use you could use variables to represent that, where c represents the circumference, d represents the diameter, and pi is just pi. This symbol right here is the Greek letter pi. The number pi has an infinite number of decimal digits. It goes on forever. It never stops. Who wants an infinite amount of pi? Check it out. Here's just the first part of pi. This is a lot of digits and it never stops. I put as many as I could fit on this page, but there's a lot more. Guys, this is what an infinite amount of pi would look like at the very beginning. But remember, it keeps on going forever and ever and ever, and you couldn't fit it in the world's biggest Jamboard. So now we know what pi is. We know what circumference is. Let's use this information to write a formula for the circumference of a circle. Remember, here's our definition of pi. We said it's equal to the ratio of circumference over diameter. So how could we use that information to write a formula for circumference? This definition is a little bit easier to work with if we write it using variables. Well, the good thing is we know how to solve one-step equations. We did that last year. And so essentially what we're trying to do here is we're trying to solve this equation for circumference. We want to know what circumference is. So the way I'm going to do that is multiply both sides by the diameter. And here's what I'm going to get. Those d's are going to cancel out. And I'll have that the diameter multiplied by pi is equal to the circumference. That is a formula for circumference. Multiply the diameter times pi and you can find the circumference of any circle without even using a piece of string. On your mathematics reference materials, you're going to see that formula written this way. The circumference is equal to pi multiplied by the diameter. Now, yesterday, you discovered that a diameter is equal to 2 radiuses, to 2 radii. The diameter is twice as long as the radius. So, think for a minute. How could you write this formula using the radius instead of the diameter? How would the formula be different if I was using the radius to find circumference instead of the diameter? Talk with your partner about it. Hit play when you're ready to discuss it as a class. So yesterday we talked about how the diameter is twice as long as the radius. The diameter is like 2 radiuses. We could write it like that. The diameter is the same as 2 radii. So to rewrite our formula in terms of the radius, all we have to do, instead of writing diameter, just write that the circumference is equal to pi multiplied by 2 times the radius. Because 2 times the radius is the same thing as the diameter. 2 radii is the same thing as 1 diameter. And normally we would write this formula like this. C equals 2 times pi times the radius. These are the same thing. These two equations say the exact same thing, but this is the one that you're going to see on your mathematics reference materials. All right, so let's do a little bit of quick practice. If the radius is 2, what's the diameter? 4. If the diameter is 6, what's the radius? It would be 3. What if the radius is 1/2? Then what's the diameter? 1. On your own paper, work with a partner to complete this table. Hit pause and then hit play again when you're ready to see the completed table. If you can complete this table, then you truly understand the relationship between the radius and the diameter.